The myth, space is completely silent. The idea that space is completely silent comes from the common understanding that sound needs a medium, like air, water, or solid materials, to travel. On Earth, when something creates a sound, it causes nearby air molecules to vibrate. These vibrations spread out in waves, eventually reaching your ear, where your brain interprets them as sound. In space, there is no atmosphere to carry these sound waves, which leads to the notion that it's a place of complete silence. Space is a near-perfect vacuum, meaning it contains very few particles, like atoms and molecules, compared to environments like Earth's atmosphere. In a vacuum, the particles are so spread out that they can't collide and pass along sound waves in the same way they do on Earth. This is why, if you were to float in space, you'd experience what's called auditory silence. You wouldn't be able to hear traditional sounds, even if they were happening right next to you. For instance, if two astronauts were standing just feet apart from each other in space without radios, they could wave at each other, gesture, or even yell, but no sound would be transmitted. This is where the image of space as a silent void comes from. But space isn't completely silent. While sound as we know it doesn't travel through the vacuum of space, it's wrong to say that space is entirely silent. In fact, space is filled with various types of electromagnetic waves, which don't require a medium like air to travel. These waves include radio waves, light waves, and X-rays, which can all move freely through space. Scientists have developed instruments that can detect these waves and convert them into something humans can hear or see. Here are some fascinating ways that space actually speaks, even though not in the conventional sense. Radio waves travel through space and can be picked up by specialized antennas or spacecraft receivers. These waves can come from a variety of cosmic sources, including stars, planets, and even distant galaxies. When scientists capture these waves, they can translate them into sound that we can hear. For example, NASA's Voyager spacecraft picked up eerie radio emissions from the planet Saturn that were converted into audio, giving us an eerie glimpse of what space sounds like. Scientists have been able to listen to space in other fascinating ways. For example, pulsars, rotating neutron stars, emit regular bursts of radiation as they spin. When these bursts of radiation are converted into sound, they resemble rhythmic beats, almost like the ticking of a clock. Similarly, certain cosmic phenomena like black holes or solar flares emit signals that can be transformed into sound waves. The sun might look serene from 93 million miles away, but it's actually a giant, fiery ball of chaos. The sun's surface constantly bubbles and boils with energy. Scientists have been able to capture solar oscillations and convert them into audio waves, producing something that sounds like a continuous hum. While we can't hear it with our ears, the sun is effectively singing at all times. Even though space is mostly a vacuum, certain regions are packed with plasma or gas, like the dense atmospheres of planets. When NASA's Juno spacecraft flew past Jupiter, it detected plasma waves within the planet's magnetic field. These plasma waves were converted into audio recordings, allowing us to hear the interaction between the planet's magnetosphere and the solar wind. Movies and TV shows often dramatize space as a place of absolute silence. Scenes where spaceships explode or fly past the screen are usually depicted in total silence. While this depiction is partially true, in the vacuum of space, you wouldn't hear explosions the way you do in Earth's atmosphere. Things can get more complicated when it comes to different regions of space. For instance, within the atmospheres of planets or moons, sound can still travel. On Mars, for example, scientists recently recorded actual sounds with the Perseverance rover. Even though Mars's atmosphere is thin, sound waves can still travel, allowing things like the wind or the noise of the rover's wheels to be heard. In dense cosmic regions, like near the center of galaxies or in nebula, clouds of gas and dust, sound could theoretically propagate because these areas have more particles than the vacuum of open space. While it's true that in the vast, empty expanses of space, sound as we know it can't travel, it's incorrect to think of space as entirely silent. Through the use of advanced technology, scientists have discovered a whole new way to listen to space, detecting the hums, roars, and rhythmic pulses of the cosmos. These space sounds, though different from traditional sounds on Earth, give us a fascinating new perspective on how active and alive the universe really is.